couldn't quite fit it all in that last screencast. So where are we? We're looking at, here's the theorem, here's the proof, here's the big picture. We're just trying to try to prove that this green part is less than epsilon over 3. Okay, we ended up with some statement that looks like this: fmx minus fmc minus fnx minus fnc over x minus c is less than epsilon over 3, as long as m and n are bigger than or equal to some capital N1. So we have this capital N1. What happens is, right, we're going to fix n, x, and c, and let m go off to infinity. And then this is really just a sequence of numbers, fm minus fm of x and c, because x and c are fixed temporarily, just a sequence of numbers. So I get am minus some constant, as far as I'm concerned, divided by some constant. Is really hard to think of all this. By the order limit theorem, this says that am minus a over b is going to go to a minus a over b, and that's going to be less than or equal to, this should be epsilon over 3, negative, less than or equal to epsilon over 3. And just to kind of remind you what the constants are. And so, well, maybe I'll just say a minus a over b has to be less than or equal to epsilon over 3, which is the same as saying, well, a is basically the limit of this sequence as m goes up. But that's really just going to be f of x minus f of c. Let's see, capital A is just fn minus fn. Minus fn of c, all divided by x minus c, which actually I could just split that up into two denominators. So if I do that, I get this. So I get this quotient, and I probably should finish off my absolute value. And what do I know? I know that this is less than or equal to epsilon over 3. So what does that give us? That gives us, by the green lemma, that this thing is less than or equal to epsilon over 3. And also over here, what we have is that we have an n1 belonging to the natural numbers that makes this true. And I need n bigger than or equal to, or how about I need my capital N bigger than or equal to, I need my capital N, this thing right here, under the pink, has to be bigger than or equal to n1 in order for this to be true. So that finishes the first third of this. So basically, I can make this thing less than or equal to epsilon over 3 as long as I pick my capital N to be bigger than or equal to n1. I had to use the mean value theorem, I had to use order limit theorems, it was big and complex, and I'm only 1/3 done, but actually these two now go really quickly after that. So stay tuned, the next screencast will start the blue and the purple, and also take care of the pink and the red, and I might be able to do it in one screencast or maybe two. So we're actually almost done.